As the transmission speeds and capacity requirements of data networks increase, demand for the use of extremely high radio frequency ranges surges as well. This means that demand for fixed radio links also is increasing. Accordingly, frequency spectrum monitoring methods also require continuous development. Radio engineers, providers, and enforcement staff, when surveying radio equipment installation sites, often encounter challenges related to difficult access to transmission equipment. It is particularly difficult to provide spectrum supervision at extremely high frequencies above 40 GHz because measurements must be conducted close to the transmitter to obtain accurate results. Those signals cannot be effectively evaluated from ground level. The option is to develop an innovative solution that could bring the measuring device to the height of the antenna and place it in the beam of the signal to be measured. This is a solution which uses machine learning algorithms and artificial intelligence to help an operator to measure and survey communication sites. The Electronic Communications Office of Latvia, in cooperation with a global leader in microwave data transmission equipment, SAF Technica, has developed a drone-based solution that will provide a more efficient process to address the ever-crowded radio frequency spectrum under a variety of regulatory and surveillance applications. This includes a radio frequency test and measurement solution mounted on an unmanned aerial vehicle. The solution includes SAF Technica's lightweight spectrum analyzer, as well as specialized computers which run dedicated machine learning software for easy data collection, storage, and analysis. The solution makes it possible to bring the measuring device automatically next to the transmitter for measurements and enables the measuring process to be controlled in real time. This automatic positioning function is a very sophisticated artificial intelligence program which can locate the optimal measurement position for each antenna and later position the measuring device in this optimal place with precision up to 1 centimeter. From both a technical and an economical point of view, this is one of the most effective solutions for radio equipment measurements if the transmitting antenna is in an environment where it is difficult to access it or if it is located at a high altitude. The innovative drone-based solution will help ensure radio frequency spectrum control, which is an integral responsibility of telecommunications regulators to safeguard the consistent application of the regulatory framework. The main benefit is that it will allow access to frequencies that could not previously be measured and allow this to be done in a sensible time frame. The solution will improve the safety and efficiency of field engineers. Tasks once performed tens of meters above ground will be achievable without climbing one step. An additional benefit is that this will save time when surveying communications sites, which equates to thousands of manual labor hours in radio frequency measurements which are performed each year. Thanks to the modular construction of the drone, it is possible to assemble it in a few minutes. Necessary safety checks and preparations are carried out before each flight. The necessary components and modules are connected to the drone, and the charge level and overall readiness of the system are checked before every flight. The drone is manually lifted into the air. When the optimum height is reached, the operator circles around the tower so that the artificial intelligence system detects all the antennas and their parameters. Antennas are detected automatically via a machine learning algorithm, which uses a separate camera to feed information to the specialized computer on board, then analyzing the information that is gathered. After circling around the tower, the operator's computer screen shows a visual representation in the space of all the determined antennas. User interface shows a visual cue on the operator's computer screen to track determined antennas and antennas still being processed. Automatic recognition of objects by using computer vision is an integral and unique function which helps the operator to work and speeds up the process significantly. The use of artificial intelligence provides a significant increase in precision and speed. During the flight, it is possible to select waypoints for the selected antennas. After creating the route, it is necessary to send a command to execute the route. The drone automatically places the measuring instrument in the optimal position. Thus, it is possible to perform reliable measurements by automatically placing the drone in the transmission beam. The operator can land the drone and conduct data analysis while conserving precious battery life. After analyzing the data, it is possible to create a route for the drone while it is still on land. After that, it is possible to execute the route by sending waypoint information to the drone for automatic flight execution. If positioning is made manually, it would take almost a full charge of batteries to position the measuring device in the proper place and to get believable measurements, which is not an effective way to work. By using the waypoint function, we can achieve consistent and optimal measurement results while saving time and other resources. Measurements can be made for several antennas during one flight. The measurement complex provides measurements in a wide range from 6 to 90 gigahertz. Individual range scanning or selected frequency measurements are also possible. The measuring instrument module consists of 4 SAF receivers. They can be combined in different variations to cover select frequency spans. Data are saved after the flight and can be retrieved right away or at a later date as needed. The determined antennas are saved with the following parameters: azimuth, diameter, height, center frequency if measured, signal level if measurements have been made, bandwidth if measured, and image from the AI camera.